Whenever we have a set of parametric equations, it is oftentimes nice to have a visual representation. And so in this graph, in this problem we are asked to find the rectangular equation and sketch the graph. Here x equals the cosine of theta, y is equal to the sine of theta, and theta runs between 0 and 2 pi. When we try to find the rectangular equation, we will usually employ the eliminating the parameter technique, and in this case we have to use a little bit of creativity. So rather than try to solve one of these equations for the parameter, which is theta in this case, we use our further knowledge of trigonometric functions. We have that the cosine of theta squared plus the sine of theta squared is equal to 1. We know that cosine of theta is equal to x by the first equation, so cosine of theta squared is the same as x squared. Sine of theta is equal to y, so sine of theta squared is equal to y squared. So this is our rectangular equation, x squared plus y squared equals 1. We should recognize that as the equation of a circle with a radius 1. So, we draw our circle. We put our x and y axis on here. The radius is 1, so this point would be the point 1, 0. This point would be the point 0, 1. Remember that any point on this unit circle can be given by an angle theta, and in that case, the coordinates of the point are given by the cosine of theta, sine of theta. As theta gets larger, this point travels around the circle in a counterclockwise direction, so this gives us our orientation. So the orientation for this graph, and I'll put it in a different color, should be counterclockwise. So there's the sketch of our plane curve associated to the parametric equations x equals cosine of theta, y equals sine of theta, where theta runs between 0 and 2 pi.